Hi, welcome to my video on AA Similarity, Part 1, Similar Triangles by AA. If three angles of one triangle are equal to three angles of another triangle, then the triangles are similar. So this is what they call the AA similarity, because it's three angles. But what we're going to prove is that we don't need three angles, we only need two. If two angles of one triangle are equal to two angles of another, then the triangles are similar. So let's look at doing this proof. And we have to start off from what we're given. So we're given, let's say, two triangles. Let's name one triangle ABC. And let's name the other triangle X, Y, W. And we're given two triangles, and we're given that two angles are equal. So let's let angle A equal angle X, and let's let angle B equal angle Y. So that's what we're given. We're given two triangles with two angles of one equal to two angles of another. And we have to prove that triangle A, B, C is similar to triangle X, Y, W. So let's do the proof. So what we have is we have statements in this column, and we have reasons in this column. So let's do number one statement. Number one statement is normally the given. So triangle ABC, triangle XYW, where we're given angle A equals angle X, and we're given angle B equals angle Y. So that's what we call the givens. We write the givens in the first statement. Now some teachers require you to put each given separate, but I don't. I just put them all in one. So number two, I put circles around just so this is a habit. So what do we have as a result of two triangles? Well, let's draw the two triangles. The two triangles are similar. One is big and one is small. Doesn't make any difference. So this is triangle A, B, C, and this is X, Y, W. Notice A goes with X, B goes with Y, C goes with W. Notice these two triangles. We're dealing with angles, so we can say that the angle A plus the angle B plus the angle C is 180 degrees, and angle X plus angle Y plus angle W is 180 degrees, and that's called the sum of the interior, INT, angles of a triangle equals 180 degrees, sum of the angle theorem, sum of the angles of a triangle. And because these are all equal to 180, now we can say that angle A plus angle B plus angle C is equal to angle X plus angle Y plus angle W. And we can say transitive property, or we could get away with, ask your teacher, substitution. But because the three of these angles are equal to 180, because the three of these are equal to 180, that means these are equal to each other. We call it a transitive property, or we can do substitution. Now that we have this equation, and we have angle A is equal to angle X, we can subtract. So we can subtract A and X out. We can subtract B and Y out. And so now we can have, because we subtract them out, we can have angle C equals angle W. And we call that the subtraction. Some teachers say subtraction. Some people say the subtraction property of equality. So again, check with your teacher. Subtraction could be okay, or subtraction property of equality. Now that we notice we started off with these two pairs equal. Now we've proven that the third pair is equal. So because we have the third pair, That means the triangles A, B, C is similar to the triangle X, Y, W. And the reason is by A, similarity. So notice we started it with two pairs equal and we proved the triangle similar. So now we have the three angles equal, so we can say AAA similarity. So from now on, if we want to prove triangles similar, to prove triangles similar, we only need two pairs of angles equal, not three. Two will do it because we just did this proof. And that's called two pairs of angles equal to prove the triangle. That's called the AA similarity. So again, to repeat, if we need to prove two triangles similar, we only need two angles in each equal. And that's what we're going to dwell on, not three. Two is sufficient by AA similarity. So, let's continue. If two pairs of corresponding angles of two triangles are equal, then the triangles are similar. And this is called the AA similarity. Complete the similarity relation in each. In other words, the similarity relation between is two triangles that are similar. So notice X goes with D. So X goes with D. Notice Y goes with E. Y is with E. And X, Y, W. W is left. So we have it. W must go with the H. And that's the similarity relation. Because we match up the triangles, each triangle with the equal angles. So let's do B. Let's take triangle, we can call it A, B, C. Let's write down triangle A, B, C. I could say this could be, I could say B, A, C. It makes no difference. So if I go A, B, C, then I'll say, what is angle A equal to? Angle A is equal to H. So A goes with H. What is B equal to? B is equal to T. So B goes with T. So C is left over. C must go with the G. If you did BAC, then you would have had B going with T. You would add A, which is equal to H. And you have C going with the G. So it makes no difference if you go ABC is similar to HTG, or you go BAC is similar to THG. Your choice. Whatever you put here, then this has to match up. C, we have, notice we have these two angles that are equal because we marked them with a dot. Now we need another pair. And there's nothing marked, but we know, or should know, and I'll explain it here, right here. If you have two intersecting lines, if two lines intersect, then the vertically opposite angles are equal. So this angle right here is equal to this one. This angle right here is equal to this one. They're called vertically, I call it the VOAT theorem, vertically opposite angle theorem. So that means we have to mark this angle, which is O. So O is really going with O. So this angle right here is equal to this one by VOAT. So that means F goes with C, O goes with O, so P must go with H. So if I write down one triangle, makes no difference. If I write down F, P, O. If I write down this triangle, FPO, F goes with C, P got to go with H, because the O is equal to the O in each triangle. Normally, if you have two angles equal, that's the ones you probably write down first and leave the third one after. D, prove that these triangles are similar. Again, we're working on the AA. We need two pairs of angles. So what I'm going to do now is draw the triangles separate. So this triangle here is A, B, C. And this triangle right here is X, W, C. We got a right angle there and a right angle there. Notice when I separate them, you can see that this angle right here, C, this angle, let me trace it out, this angle is in both triangles. So that's what we call a common angle. So if an angle is in both triangles, that angle must be equal to itself. It's called, and in proofs that you did in the videos on congruent triangles, then we say this angle C is equal to angle C by a common angle to the triangles. So what we have, if we take the triangle A, B, C, which is this one, the big one, let's write down A, B, C. A is going with X, B is equal to W, and C goes with C. So that's the triangles that are similar. But notice I drew the two triangles separate. You can see how they're going to be similar with the AA similarity. In E, we have this diagram like a butterfly. And again, what we have here is that we have this angle right here that's equal to this one because of VOAT, vertically opposite angles. So if I take the triangle JLK, J is equal to P, L is equal to L in each of the triangles. This is the vertically opposite angles by intersecting lines. There's two lines intersecting. These two angles are equal. Now these angles here, this one, JLP, is equal to MLK, but we don't need these two. We only need the two that are in the triangles. And K must go with M because that's the angles that are left over. So that's dealing with just naming the triangles by the similarity relation. Remember, it's the AA similarity we're using. And practice. See if you can write the correct similarity relations for these 5. Pause your video and work one out at a time. When you get one done, press play, see if your answer's right. And do one at a time. Complete the similarity relation in each. So we have these two triangles. We have, let's name this triangle FHO. FHO. F is equal to A because they both have 2 strokes. H is equal to C because they have 1 stroke. And O goes with A. That's what's left over. So that's the AA similarity. Triangles are similar. 2 angles equal. Number 2, we have again 2 triangles. Notice that C is equal to P and B is equal to Z. So name this triangle. We can say A, B, C. So as a result, A is going with X. B is going with V. And C is going with P. So notice C is with P, B is with V, so A must go with X because that's what's left over. And again, 2 pairs of angles equal in a triangle are similar. Number 3, we have 2 triangles. Well, let's again separate the triangles like this. We got the big one, which is HCT, and we have the small one. Okay, the small one is HUW. Now, because of the parallel lines, we have many of them here. Notice that H right here is a common angle to the 2 triangles. So this angle H. Also, because of the parallel lines, we have this angle right here equal to this one. So this angle HUW is equal to angle HCT because of what we call the corresponding angles. Two lines are parallel, the corresponding angles are equal. So, and also, as it happens, because of the parallel lines, this angle right here is equal to this one. So I can name all three angles, or just any two, but I only need two. I don't need all three. So if I go with triangle HCT, similar to H goes with H, C goes with U, and T goes with W because of the markings. And again, we only need two angles, so I didn't need the three. So if I did these two pairs, I didn't need this one. If I did this pair and this pair, I didn't need this pair. So only two will do. I don't need three. And, I wrote that. Oh, I'm sorry. I was dealing with that and I put it in the wrong spot. Sorry for that. One of those talking too much. That's what I'm doing. So I'll do this one down here now. Sorry for that. I put the answer here instead of up here. Okay, let's continue. Number 4. And I have, notice, just two different triangles. So let's take the triangle ETH, and that's this one. And notice we have a right angle here, and it's perpendicular, so that means there's a right angle right here. And let's do the other one, which is XTV with a right angle. So if we take ETH, which is this triangle, and E is equal to X, which is this one right here, so we got to name that with an X, and T is equal to T, because there's right angles, and so that means the H must go with the V. And again, two pairs of angles equal, so we have T, these two angles are equal right here, and this angle E is equal to angle X is the other pair. So these triangles are similar because we have two pairs of angles equal. And number 5, let's see what we have. We have parallel lines again. Every time you get parallel lines, you should see a pair of angles equal. That's the thing. Parallel lines will give you equal angles. So I have, again, lots of options. I notice I have many options here. I only need two. So if I name this angle is equal to this one, parallel lines gives me these two angles equal. Angle X equals angle H. Also, the parallel lines will give me the angle at Y equal to the angle at T. Notice these parallel lines now give you alternate interior angles. Let me explain. If you have two parallel lines and you have a transversal cutting through, there's parallel lines, then the alternate interior, so that means that that angle right there is equal to this one, alternate across the transversal, or you got this angle right here equal to this one by alternate interior. So this is alternate interior. There's the parallel lines, and there's the transversal, and you're going from one side to the other, or the same with these two. Here's the parallel lines. This is the transversal. So these are on opposite sides of they're alternate interiors. So if I name triangle XYW, X goes with H, Y goes with T, and W is left goes with W. And also, this angle right here, and this angle, so YWX and TWH, this angle equals this one. This angle right here is equal to W is equal to W because they're VOAT, vertically opposite angles. But I only need two, so I went with these two because of the parallel lines, alternate interior angles equal. So that's dealing with proving or getting triangles similar by AA similarity. And hopefully you enjoyed my video. If you did, click the like button, click the subscribe button, click the notification bell. and visit my math website, www.mathfullyexplained.com, and to find more information about me, my videos, and the content that's on my YouTube channel called Math Fully Explained. Thank you very much for viewing my video. Bye-bye.